can I say about Kevlin Henney? Well, I could stand up here and talk a lot, but just let me say a few things. He's an independent consultant, speaker, writer, and trainer with a focus on programming, practice, and people. He's the co-author of 2 volumes in the Pattern-Oriented Software Architecture series. He's the editor of 97 Things Every Programmer Should Know and co-editor of 97 Things Every Java Programmer Should Know. The title of his talk is Technical Neglect. Please put your hands together for Kevlin Henney.
Thanks. All right, okay, so what we're going to talk about today is actually a kind of follow-on of a talk that I did here 1 year ago, and I got some really good feedback from it. Last year I talked about metaphors we code by. There's a metaphor that I have been using really for the last 2.5 years, and it started sneaking into my workshops and a couple of my talks around 2 years ago. And so now I'm going to give it kind of this kind of more central position. I've started giving this as a kind of the main talk idea. I want to talk about technical neglect. What I mean by that, what it entails, and why it is that we want to consider using this when we are talking about some of the struggles that we may have within our architectures and within our code bases. So yeah, I'm Kevlin Henney. I used to just put one social media contact detail up, but I have no idea where I am these days. I'm everywhere. You can find me. If you want to stalk me online, that's absolutely fine. Connect with me on LinkedIn. That's great. And I stumbled across this quote of mine recently, kind of by accident, and I thought, you know what, this fits this talk perfectly. The words shape what we think. So if we choose the wrong words, it will take longer to discover the thing that matters. In software, words and language matter immensely, because there isn't a lot else. If you open up a file of source code, what do you have? You have words, you have punctuation, you have spacing. Those are your tools. That's it. There isn't anything else, okay? Everything else is about what we do with those. So anybody who just dismisses something and sort of says, oh yeah, Kevlin, focusing on words, that's just semantics. I want to remind you what semantics means. It means meaning. If you say, oh, this whole system of meaning that we're building, that's just meaning, you've just described your job. So yes, it is the part of your job that is your job. What do we mean and what are we trying to talk about? And importantly, when we talk about the thing we're talking about, as opposed to here is this element of software, here is this class, this object, this function, how do we talk about the collective stuff? Now, one of the interesting things that we have is a little bit of confusion. Now, this is not just unique to software developers. We actually see this as a trait across humans. We often mix up cause and effect. A lot of people will say, oh, you know, we have a technical debt problem. Now, I'm not going to say that they're necessarily wrong. They often do have a technical debt problem. But that is not helping them understand what to do about it. They are focused on an effect. Technical debt is not a cause, it is an effect. It is a thing that you see and observe. The thing that you want to do, if you want to solve it, if you just want to talk about it, keep talking about technical debt. If you actually want to do something about it, you have to understand what the cause is. And in many cases, what people are actually complaining about is technical neglect. And why is it so hard? Why has it taken us so long to uncover this metaphor? Because technical neglect is not a thing that you do. And I think as software developers, as people who work in offices and who communicate face-to-face, online, via Slack, we are good at action. We are good at doing things. So I can say, oh, look, they're doing a thing. They are fixing a bug. They are developing a feature. They are sitting in a meeting. They are playing buzzword bingo in that meeting. I can see action. We quantify action. We point to it. Neglect is not a thing that you do. Neglect is a thing that you don't do. It is an absence of a thing. That's why it's so hard to see. There is something that is not happening. That is the thing that you want. That's the cause. And it leads to stuff like this. This is a shack that has been left alone for around 30 or 40 years. I happen to know that because it's in the Chernobyl exclusion zone. And I saw it in 2019, so I can tell you pretty much the mid-1980s to 2019, that's how long it's been since anybody did anything to maintain this hut. So humans have not interacted with this, and it has become neglected, quite literally. Okay? It's a thing that doesn't happen. Our involvement did not happen. So, here's a boat. Why am I showing you a boat? I'm showing you a boat because I want to give you an example of what I mean in terms of how people go about dealing with their problems of legacy code, unmanaged technical debt, and things like that. And I want to describe the problem not in terms of software, but in terms of a boat that has a hole and it's letting water in. And I want to tell you how software people solve it, and then I want to tell you how everybody else on the planet solves it. You are in a boat, you are out on the water. There is a hole in the boat. Maybe if you want to make it more dramatic, there are lots of holes. If you want to make it really exciting, we can fill the water with sharks. I don't care. I'll leave that to you. Create your own scenario. We are taking on water. Here is how a software person will solve this. You know what? Well, actually, there's two ways. One way is there's a software person going, well, this always happens. Yeah, this always happens. And you sink, okay? Yeah, this is software development, okay? It's learned helplessness, okay? I'm not interested in that particular one. What everybody else is going to do is they're going to go like, you know what? We need to get the water out the boat. We need to quantify the water. We need to get the water out of the boat. And you know what happens? Sometimes the good thing happens. We get really good at emptying the water from the boat. What does everybody else do? They stop the water coming in. Both are necessary, but you really need to stop the water coming in. And I had this experience with a couple of clients over the years where I've run workshops and so on. Like, we've got this legacy code problem. We've got these issues of unmanaged technical debt. How do we address them? Okay, here's a plan. We come up with ideas and approaches. And this is great. And sometimes they even try them out. But what is then interesting, and I had this with one client where they actually did do that, and then a couple of years later they contacted me again and said, hey, we've got the same problem again. Because it turns out what I thought was implicitly obvious to me, but I never stated, was you've also got to learn how not to create the problem. You can't just fix the problem, you have to learn how to stop creating it. You've got to stop the water coming in. So, I'm going to take you back to 1980. This is actually Meyer Lehman's work throughout the 1970s. So although this paper is 1980, it actually has it's really the culmination of his work in the 70s. Now, the time period is important. I want to give you a sense of the when of it and how far back this is. As an evolving program is continually changed, its complexity, reflecting deteriorating structure, increases unless work is done to maintain or reduce it. Now, I really like this observation. There's something here that I think is, you can actually pick apart these words and there's a lot to be revealed. He is basically saying, it's inevitable that you will need to do extra work. And this is a really important point because a lot of people say, oh yeah, it's to do with whether or not you're doing good coding. What we're actually saying here is even if you are doing the good stuff, whatever we mean by good, you will still need to maintain it and clean it up. Why are we saying this? Normally people say, well, yeah, you just do the good job and then that's it, you're done. You only need to do the extra work if you've done a bad job or if something else changed. No, we're actually saying this is inevitable, and it's actually built into the universe. Second law of thermodynamics and all kinds of stuff like that, which I won't go into just yet. But I want to give you a very simple example. The fact is that you will when you are, let's just say, you are this is obviously not going to be true. It may be true from a personal point of view. You are the best software developer in the room, okay? I want you to keep that. You have the best techniques. And we've got a decent code base. And you're now going to do some work on it. And you're going to have the best focus, the best attention, and you're going to do your best work. You know what? You still need to clean up. What? Why? Because of a word I just mentioned, focus. By definition, if you are focused on something, by definition, it means you're not focused on something else. Or to be precise, no, on something else. If you are focused on one thing, it means you are ignoring everything else. That's the whole point of attention. We gather the attention, I'm focused on this function, this class, this service, whatever I am focused on. It by definition means I am ignoring everything else. And even if I do the best job, I will miss the fact that perhaps I could have changed something somewhere else as well. Perhaps I've invalidated a pre-existing assumption. Perhaps I've introduced an inconsistency. I don't know what it is, because I don't know, because I'm so busy focused on the one thing. And it might not be me that realizes it. It might be future me or one of my colleagues. The idea is that when you are focused on something, you are going to introduce change. By changing a system, you have changed the system. And a code base is a system. And you've upset its equilibrium, even if it was, let's imagine it's perfect. You've upset it, even if you've done your best change. But as I said, this is built into the universe. So I work from home a lot, which means that often I'm going to feed myself, or I'm going to feed my young one or my wife, and it's just like, okay, I'll do lunch. And what do I say? I say, I'll go and make lunch. I don't say, you know what, I'm going into the kitchen to make a mess. Oh, by the way, a side effect is that we will be able to eat. But by definition, the very act of creating even the best meal will involve creating something of a mess. Even if I tidy as I go, I still have additional work to do. So this is the whole point. Notice he says, it's inevitable. Deteriorating structure unless you put in extra work. And he specifically says, unless work is done to maintain or reduce it. I like the fact that he uses the word maintain, because we've ended up using the word maintenance in software to mean something completely different. I would argue that he is using maintenance more correctly here. We use the term maintenance to mean a number of things. One of the most popular interpretations of maintenance is bug fixing. I'm sorry, that's a terrible, terrible term if you use it in your organization. It's very popular, but it's a terrible term. It's a euphemistic term. It allows people to say, oh yes, this software, this code base is going into maintenance. Oh, you mean fixing. We built a broken thing, now we're going to fix it. Yeah? If you start putting that on slides and budgets, people get really upset. So maintenance feels like a smooth, gentle word. You're not maintaining it. You're actually making it what it should have been. Now, again, this is not an argument for perfection, it's just an argument for honesty. It's not maintenance, it's defect removal. Yeah? If I get a car and there is a bug or a defect in that car, it gets recalled. Maintenance is, oh, the tires are wearing down. The oil needs to be changed. Natural wear and tear through interaction. What we're saying is that the interaction, me as a developer doing stuff. Okay? That's the interaction we're interested in. We need to maintain that. We need to always account for extra work. Now, the messier the code is, or the sloppier our work is, or the less we knew about what we were going to do, the more likely it is there will be more maintenance work. But we're saying that there will always be maintenance work. So this is a better interpretation of the metaphor. So let's talk about metaphors for a moment, because that's what my talk was last year. If I go to the OED, metaphor, the figure of speech in which a name or descriptive term is transferred to some object different from but analogous to that which it is properly applicable. It literally comes from the Greek metaphora, meaning to transfer. What I am trying to do is understand or experience something else in terms of something that is probably more familiar. Understand one thing in terms of another. It's effectively a mapping. And we do that for exactly the reasons I've described. Understanding, comprehension. And typically what we do is we say, here is a thing that is abstract or complex or unfamiliar. Here is a thing that is familiar and concrete and simple. And I'm going to help you understand this by navigating via this. That's what we're doing. That's great. We use it everywhere in software because software is not made of kickable stuff. Yeah, what I mean by kickable is that. Hopefully I won't be charged for that. But kickable is physical. Software is not kickable. Sometimes you want it to be. That's different. That's an emotional response. We all have them. And it's unsatisfying because there's nothing there to kick. Yeah, what we do is abstract stuff. But in doing that, if you look, so here's a shot of my office, from my office. And so what have I got in there? Well, that's a window. Yeah, if you've got a desktop, you've got windows on it. They're not really windows. When I look at Word or I open up a browser, it's not really a window. That's a metaphor. But if I started using other terms, it would feel weird. But a window has a number of implications. I mean, you've got frames. If you're programming, there's frames. Similarly, we have the idea of there is a view. I didn't realize this when I originally took the picture, but it turns out that I've also got a model in my picture as well. So model view. Nice. Yes, there is a controller. There's a guitar pedal just off to the right that is a controller. I'm not going to label it, but there we go. We have a set of actions, metaphorical entailments. I can close a window. Yeah? So we have that idea. It gives me a language through which to reason. But of course, it's not perfect. I mean, resizing a window? I mean, do you know how expensive it is to resize a window? How messy it is? Yeah. And likewise, I've got a blind there. I mean, I don't see that in any UI frameworks. So there is this observation. By definition, this mapping is never perfect. So whenever people sort of say, oh, that metaphor is not perfect, well done, congratulations, you've just described what a metaphor is. Yeah? That's not our problem. Of course it's not perfect. It's a conceit. It's not identity. If it were exactly the same thing, then it wouldn't be a metaphor. Yeah? But that doesn't mean that we can't have a discussion about the appropriateness or quality of a metaphor. So I wrote this in a piece for O'Reilly Radar back in 2020 on exactitude and technical debt, where I basically said, here's 3 ways you can evaluate whether we consider a particular metaphor good. To be considered good, a metaphor has to offer a number of points of useful correspondence with what is being described. So let me take a fairly familiar metaphor that we find extensively used. This is an iceberg. The observation is, fairly reasonable. If you look at this picture, you can see that some of the iceberg is below the water. It's not a surprise, but actually almost all of it is. To be precise, because of the density differential between liquid and the solid phase of water, what we find is that the density decreases by about 9%, which basically means you were looking at around, most of this, 90% is under the water. Now, this gives rise to a variety of metaphors. So I went to the internet and you go, oh, here's the iceberg illusion. People often use this to convey things like success is an iceberg. Here's success, it's the little bit above, and here's all the stuff you don't see. You find it popping up in psychology and pop psychology, behavior, emotions, perception, all the rest of it. You find it in DevOps. There we go, the DevOps iceberg. One of my favorites is this one. There are more iceberg metaphors than there are actual icebergs. Actual icebergs of the world today, iceberg metaphors used at conferences. In fact, I just typed in iceberg metaphor. My goodness, there's a lot. So the point there is that we are clearly drawing some kind of visual comparison. And that's a useful point of correspondence. Another quality of a good metaphor, so point 2, is that it should not have too many obvious points of conflict. This is where it gets interesting. We want the points of correspondence. This is the thing. I've got the thing over here that I need to explain to you and reason about, and I've got the thing over here. I need there to be really clear points. But there will be points that conflict. The question is, are they problematic? So this piece from Isabel Amos Landgraf. Imagine an iceberg floating in the ocean. Most people imagine a tall, pointy chunk of ice with a huge hidden section underwater. Now, while it's true that only 10% of an iceberg sits above the surface, popular portrayals of icebergs are often inaccurate because any elongated iceberg will float with its long axis parallel to the water's surface. Let me translate that for you. They're on their side. They don't do this. They do not do this, which I'm going to show you. Now, this is interesting. There's a viral tweet that went viral a couple of years back, and there's an interactive website. You can play with this. You can find out how icebergs actually work. The viral tweet came from Megan Thompson-Munson, who actually specializes in this. She said, "Today I channeled my energy into this very unofficial but passionate petition for scientists to start drawing icebergs in their stable orientations." Okay, so she painted one. She had, during the lockdown, what are you going to do? Well, let's learn how to paint. The classic image of an iceberg is usually some kind of ice cream cone, like that. And I love the fact she says, "Source every iceberg stock photo on the internet. I refer you again to this. Look at them." So this is the website. Joshua Talborough did this. You can find it at joshdata.me, iceberger.html. Draw an iceberg on the screen with your finger or your stylus, and then see what happens. There we go. If that particular one I measured went through 46 degrees. So it turns out that icebergs don't look at all like people think icebergs look like. They're actually not berg-like. They are not mountain-like at all. They're lumps. Yeah, they're very unexciting. Okay, point number 3. This is very context sensitive. Everything else has been mostly about universals that we can probably agree on, or intersubjective agreement. The third quality of a metaphor is that that makes it effective is familiarity to its audience. This is the big it depends. Who are you communicating to? If I want to get across a complex concept related to our code quality, related to our development practices, that's very abstract, who is the person or the people that are listening? Okay? Because if I offer them a mapping and it doesn't mean anything to them, then I now have a problem. I'm going to explain this thing that's complex and unknown to you using another thing that's unknown to you as well. So I'm going to have to, no. Too many levels of indirection. Actually, quite a good example for this, to bring us back to the technical debt aspect, is this observation. Bad code isn't technical debt. Well, first of all, I disagree with that because it's definitely starting on the idea that a metaphor is correct or is not. To say is not is a very absolute statement. That's not the bit I want to focus on. Bad code isn't technical debt, it's an unhedged call option. First of all, who here in this room has heard of an unhedged call option? Okay, that's a have. Who here in this room will be able to describe an unhedged call option? Okay. Does this mean that it's a bad metaphor? No, for this audience it is. A terrible metaphor, though. It's a terrible metaphor for this audience, and we've just measured that. For people in fintech, this is a really interesting analogy. That's somebody else's observation. Exactly. That's your target. If that is your target audience, if you are talking to a bunch of people in fintech, a bunch of people who know trading, this is fantastic. If you are talking to a bunch of people that have no idea what unhedged call option means, I mean, I understand the individual words, but every time I look at that, I have to remind myself what that means. It's not a good metaphor for me. So that is the thing. This is also, by the way, tells you why debt might be quite popular. Let's look at other terms that we use in this connection. So let's raid the dictionary again. Thing about the Oxford English Dictionary that is interesting is that if you want to find out what a word means and how to use it correctly, this dictionary is entirely useless to you. That's not what it's for. It's not a usage dictionary. A usage dictionary lists the most common usage first, then the next most common, and so on. This is an etymological dictionary. It's a dictionary of the history of words. The first entry is not the most common, it's the oldest. So if you're a word nerd, this is fantastic. You can lose yourself in this for hours. This is why I own a copy. But I want to focus on the word legacy, because we often use this in connection with code. And legacy normally is something positive. We talk about the legacy that somebody will leave behind. And it's normally, by default, without any other words, it's normally positive. We normally have to add another word to make it negative. Oh, he left a terrible legacy to his children. Okay? We have to add another word. Her legacy was strong, or she left a legacy. If I say nothing else about it, that's by default good. Somehow in software, we've managed to turn it upside down. By default, when we say legacy, we are not jumping for joy. We are not smiling, except because we're filling out our CV. Legacy, we've inverted the meaning, just like we did with trees, yeah? My kids thought I was kidding when I said, oh yeah, by the way, in software, trees have their root at the top and the leaves are at the bottom. And my kids are going like, you are joking. No, there's a whole discipline out there that believes this. Yeah, thanks, Dad. I'm not doing computer science. Okay, there we go. My job was done. Don't do this to your children, yeah? Okay, so what is interesting about this particular word, we see this, designating software or hardware which, although outdated or limiting, is an integral part of a computer system and difficult to replace. There are a number of reasons why a system might become legacy in this sense. But the thing to me that I find interesting, and that you may find interesting, and you will respond differently because you are an audience of different people, it depends on how old you are, is this thing here, 1989. If you're of a certain age, you will think, 1989, wow, that's really old. That's before I was born. That's before I cared about software. If anything exists before you were born, it's natural and it's always been there. If, however, you are like me and perhaps a little older, you look at this and are actually quite surprised at how late this term was coined. 1989, wow. So we didn't have a word for this stuff? I mean, when Meyer Lehman did his research in the 70s and he wrote that paper in 1980, it was another 9 years before we had the word. Wow, that's astonishing. What did we talk about? Oh, we just complained about it, but we didn't have specific words. So there are lots of definitions. I run legacy code workshops. This is one of the most common definitions that people give me. Legacy code is often defined as code that someone else wrote. This is an informal, nobody will ever put this on a company slide, but every time I run a workshop, this comes up. This is the informal definition. Yeah? Oh, I don't write legacy code, you write legacy code. Although some people are very honest. I've actually had somebody in a recent workshop write legacy code that I wrote yesterday. Yeah? 24 hours, that's all it took. 24 hours and we got the same person. But this one was interesting. Came across this one. Angel Sierra. Legacy code is often defined as code that makes more design decisions than the team working on it. Now, I can't find anybody else who said this, so Angel gets the, as far as I'm concerned, they are the source of this, but I think this is a brilliant definition, or a brilliant way of thinking about it. Code that makes more design decisions than the team working on it. I love this idea that the code is sitting at the table. You're having a meeting. Okay, so we're going to do this, and the code is just sitting there in the corner going, no, you're not. Nope, I get the final vote. I get the veto. This is not happening. We're going to deliver this with all the new functionality in the next quarter. And the code's going, not happening. The code is the sleeping partner here with the greatest vote power. But I also like the observation they go on to make. Could we define a legacy process as one that makes more decisions on how a team functions than the team itself? There's some really useful ways of looking at this and talking about this. And if you like, that's what I'm trying to do in this session, is trying to reveal what it is and how, tools for talking, tools for communicating, tools for dealing with things that are intangible and unkickable, and yet allow us to make some kind of progress and move us to action. So, yeah, there's a whole lot, there's a whole load of online, a whole load of surveys and reports online. I picked this one kind of at random, but a US-centered report, over $1 trillion to keep the lights on. Legacies drag on productivity. $1 trillion is a big number. Okay? Wow, okay, we don't even know what that, as a human being, I have no idea what that means. I mean, I can write it down, I can write down the zeros, but that still doesn't mean anything to me. It's just a very large number. Now, what is interesting is the breakdown of the numbers. In 2019, a US Government Accountability Office report found the federal government spends more than $100 billion on IT and cyber-related investments annually. Again, we don't know how to interpret this number, it's just big. It's the next bit that becomes interesting. Of this amount, agencies have typically spent about 80% on the operations and maintenance of existing IT investments, including legacy systems. Oh, it's not the fact that it's 100 billion that we're dealing with, it's the fact that it's a really big proportion of that is being referred to as stuff we have, stuff that we consider to be legacy. In fact, it goes on a bit further. On average, 31% of an organization's technology is made up of legacy systems. That's a curiously precise number, which I don't think can be justified without having error bars, but nonetheless, it also feels a little bit low, if anything. But let's just work with that, because it's the relation between this number and the next numbers. We're saying, in this case, that the minority of the technology is legacy. So that means it should be a minority of the expenditure, right? Ah, that's not how it works. What we then say is, yeah, this is going to cost you 60 to 80% of the IT budget. Oh, that's the problem. It's not the problem that it's a third or any other number. It's the problem that what we seem to be paying for it is disproportionate. Legacy technologies hamper efficiencies and restrict growth in an estimated nearly 90% of businesses. Okay, that's the thing that's interesting. It's a constant drag factor. So what we need to be worried about is the creation of legacy code. And where does it come from? Well, one of the areas I'd talk about is neglect. I also want to highlight another area. It turns out that as an industry, we have preserved our jobs into the future. We have automated the creation of legacy code. Folks, I give you LLMs. I made this, I posted this on Mastodon over a year ago. The practical consequences of using LLMs to generate code is many developers will find they have unwittingly moved themselves into a role they were probably trying to avoid. They have automated the creation of legacy code and have redefined their jobs as debugging and fixing such code. Because if you have generated that code, you did not write it. But now you've got to fix it. It's your job to deal with it. Now, I'm not saying this is not a kind of a rant against LLMs. There are plenty of those around. You can take your pick. It's not to say that they can't make you effective. It's just to say that most people will not only not be effective, they will actually create more problems for themselves than they had before they used LLMs, and they will not be aware of it. And if you are thinking, I'm special, I'm one of the few percent that knows how to use it and do it well, you are probably wrong. This is what unaware means. You're not aware that you're doing it. There are some people who are going to use this to maximal advantage, who really know what they're doing. And there is a gap that is going to increase as a result. Most people are going to become the thing that they were trying to avoid, the legacy code programmers. They will create their own legacy. Now, I said this over a year ago. I'm standing here making wild claims. Is there any evidence for this? Well, yeah, there is. It actually came out sooner than I expected. That was just a random comment that I made. In April, in January, this report was published from GitClear, Coding on Copilot. 2023 data shows downward pressure on code quality, 150 million lines of analyzed code. Okay. They kind of looked at, issues in code and whatever, and this was part of their observation. We find disconcerting trends for maintainability. Code churn, the percentage of lines that are reverted or updated less than 2 weeks after being authored, is projected to double in 2024 compared to its 2021 pre-AI baseline. In other words, we're going to get really busy. Apparently, busyness is good. Yeah, this is the misinterpretation people have often of velocity. They focus on speed and busyness. That's not what we want. So this is why sometimes people think, this is really helping me, because I feel busier. See, the AI is making me busier. I'm getting so much done. And now I've got to do things with the thing that I just did, and they're busy. But let's be a little more concrete. And I think this is really interesting because this is, funnily enough, how I would characterize some of the problems that we see in codebases. And obviously, confirmation bias is that they agree. They observe. We further find the percentage of added code and copy and pasted code is increasing in proportion to updated, deleted, and moved code. For me, when you're working with code, what shows healthy change is, oh, we're getting rid of stuff we don't need. We're moving things around. We're reshaping the code in response to the responsibilities as we understand them. Okay, we're reshaping it. It's just like, yeah, we're aligning it, updating things as necessary. In other words, it's more of a sculpting thing. Addition of code is normally a problem. Copy and pasting of code is the problem. And indeed, we find this, and this is the interesting observation that they made. When they open the paper, they sort of say, what we're interested in is to find out whether or not working with an LLM is like having a senior developer working alongside you who has great expertise in your code base, or is it like having a short-term contract developer passing through your code base? Hey, guess what? The answer is the second. It's like having somebody come in and go, yeah, I don't really know what's going on, I'm just going to add stuff. That is a problem. And it's just going to get bigger. So yes, your jobs are safe. Now, it also highlights that the issue here is not to do with tooling. To demonstrate this, I tweeted this a couple of years back. One of the great things about languages with modern IDE support is that thanks to refactoring tool, legacy code is a thing of the past. Unlike with older languages, developers never have to experience long methods, rambling classes, poor identifier names, complex logic. I envy all of you who have only been developing in the last few years. You have come into an industry that is free of legacy problems. Every time you open a file, all the methods are short and direct and well named and understood. You never have to deal with complex logic. I am so jealous of you. That's the stuff we used to have to deal with. Yeah, maybe I'm not being serious here. The point is, 20 years is how long we've had mainstream automated refactoring. And what we have learnt is that most people know how to use rename occasionally, extract method sometimes, and that is it. The problem was never the tools. It was never the tools, it was us. I'm not blaming us, I'm just saying, guess what? Humans, hey. So we need to understand a little better about our relationship. The idea that a tool is going to solve your problem, it will only solve the problem if you are prepared to change something about you. The tool is just sitting there passively waiting to be used effectively. Yeah? LLMs, refactoring tools, anything else you care to name. So let us look at some of these other things. Legacy code. Spaghetti code. That's not necessarily an effective metaphor. It's a visual description of structure, but for me it doesn't mean bad. I love spaghetti. If you tell me this code is like spaghetti, I'm going like, tasty. But it has spawned a number of other pasta metaphors. People often go, oh yeah, you want lasagna code, layered, ravioli code, and then depends how old the person is. Yeah, ravioli code for some people means objects, for others it means components, for others it means it's services, for others it means microservices. Pick a generation, they will adopt ravioli. Code rot. Software decay. I quite like these because they give you a sense of the degeneration of this stuff. The problem with these metaphors, though, is that they require nature to do something. If I leave something alone for a long time, it rots. Okay, if I leave something in my fridge for a few days, it goes off. I didn't have to do anything. If you leave code for a few years, it does nothing. The world around it changes, but that's an extrinsic change, that's not an intrinsic change. So that's the problem with this metaphor. Although it has some of the right connotations, the fact that it requires an additional agency from nature is a problem. Software entropy, there's actually a session after this that focuses on software entropy. That used to be my favorite. The problem is, I realized that in the company that I was at, many of us had degrees in physics. And so this made perfect sense. The problem is if I then have to explain the physical concept here, it's a bit annoying. But it has most of the right connotations, but you need your audience. Technical debt is the one that we're normally attracted to. Unhedged call option, we've seen. Housework, that's interesting. We're going to come back to that one. So, technical debt is indeed, as Martin Fowler originally observed, a wonderful metaphor. It comes from Ward Cunningham. It allows us to have a discussion about something that is relatively abstract in terms of something that is relatively familiar. Most people have an experience or a concept of debt. In this metaphor, doing things the quick and dirty way sets us up with a technical debt, which is similar to a financial debt. However, the problem in the phrasing is perhaps a lot of people picked up the idea of quick and dirty, which is not a positive thing. And a lot of people came to associate, and obviously many people have certain experiences of debt that are negative. So they leaned on the negative connotations. Whereas if we actually see what Ward wrote, that was not what he was doing. He was inviting you to make a decision. Shipping first-time code is like going into debt. A little debt speeds development so long as it is paid back promptly with a rewrite. The idea is that you are making a conscious decision. I don't actually know what the customer wants, so let's try out this feature and see. I won't put more time into it than is necessary. We will, as it were, sound them out and find out how they respond. And then we will invest accordingly. Or this is the first time we're using this framework, and honestly, we probably should come back and review what we're doing because there's probably a better way to do it. Or we don't have enough time to do this before that deadline, but we're going to take an option to get something out that is half adequate, and then we pay it back later. The whole point is it's a borrowing metaphor. Yeah, we focus on the debt, but the whole idea is it's borrowing. You borrow something and then you give it back. We're really bad at the second one, the giving back, the paying back. He even highlights the danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. So in other words, he says this is the negative side. He's not saying this is the metaphor. He's saying this is the negative side. This is its weakness. And he's actually making that explicit. So yeah, debt has two sides to it. So this also highlights this aspect. Although we know by definition no metaphor is perfect, two common ways in which this metaphor is misapplied. Assuming technical debt is necessarily something bad. If you have a debt, if you have a managed debt, so my wife and I had a mortgage, perfectly managed, not accidental. You know, you don't wake up one morning and suddenly, oh my goodness, we owe a whole load of money. It's managed, and what do we get in return? A house. And a structured repayment model. Excellent. Well, that seems like a reasonable way of doing things. Equating technical debt with the financial debt value. This is toxic. There are tools that will turn the technical debt in your code into a euro value. We have a technical term for this conversion rate. It's called bullshit. It is pure pseudoscience, and even worse, it is misleading and misrepresentative. It is solidly bad science. Do not have any truck with this. These tools have no idea. You cannot feed them enough information. It's just not a possibility. I don't know if a piece of duplicate code is debt or not until I understand the context. Sometimes we decouple code by duplication. And what I'm doing there is I'm trading off duplication versus coupling. If I just read duplication and I say, oh, that's going to cost you 100 euros, no, it doesn't. That's just a made-up number. There is no science behind it. Okay? Have no truck with these tools. Do not get involved with them. Similarly, if I have a whole load of code that is not actually reachable, then that's dead code. Of course, I want to get rid of it. I want to write that off. But it doesn't have the same value as a piece of code that we use and update frequently. Yeah? So this is pure nonsense on stilts. So this also tells us that another thing we have an issue with is when we use the term technical debt, probably what most people should be talking about is unmanaged technical debt. There's a special word there. Because if somebody says, oh, Kevlin, we have a whole load of technical debt. Okay, do you have a problem? What? Well, I've just told you we have technical debt. Yeah, but you haven't told me anything about it. If you said, on the other hand, oh, Kevlin, we have technical debt, we're managing it, we've got a proper repayment model, we actually manage it and prioritize it and do stuff, well done, you're managing it. Job done. You don't have a problem. You do have debt, but you don't have a debt problem. The real issue here is what people need to start saying, more honestly, is we have unmanaged technical debt. That's the thing you want to say. It's a difficult thing to say. Martin actually chooses a different word. He talks about reckless. Reckless has a moral side to it. Unmanaged is more neutral. I prefer that. Managed and unmanaged. What you want to do is communicate that. We are not managing it. Okay. So how does that arise? Where does that come from? So from that point of view, that's the message of the technical debt metaphor. It's not simply a measure of the specific work needed to repay the debt. It is the additional time and effort added to all the past, present, and future work that comes from doing it. That's the issue. It's not, and it's also not the, so it's not the value now. The amount of debt we have now would take us 2 weeks to repay or 1 month to repay. That's not your debt value. That's your today's repayment. How much extra work did it add in the past? That's the question you want to be asking. So, let's talk about Yvonne Lamb's observation. My theory of tech debt is that housework is the correct metaphor for the thing we call tech debt, but we can't use it because tech has been made up of people who don't do housework or manage housework being done. Remember I said it's to do with familiarity to the target audience? Housework is think about it for a moment. You cannot live in a house without doing extra work. Even if you're doing the right thing, you will still end up with something not being in the right place, something that needs to be cleaned, moved, turned off, turned on, or whatever. It's an inevitability. How do you organize that? It is a thing that needs to be managed. So what we're dealing with here, sticking with this, the great software engineer Isabella Beaton. She lived in the 19th century. Now, normally when we think of software engineers who lived before our times in the 19th century, we might think, Ada Lovelace. She's actually a contemporary of Ada Lovelace. She died very young. But the clever thing is that she didn't write about software. She didn't know Charles Babbage, although she was a contemporary. She died sadly very young. I don't think she even reached her 30th birthday. But she wrote a book that was highly influential in the UK, the Book of Household Management. Cleverly, she disguised all of her software engineering advice using the metaphor of a house. Smart. And when it came to the kitchen, she told us how to do this. There is no work like early work. Clear as you go. Muddle makes more muddle. Not to wash plates and dishes soon after using makes more work. It's a very simple idea. If you don't do stuff, it just piles up. We're all sick to death of exponential curves in this post-pandemic era, but there's an exponential curve. If you don't shift the stuff, then it just piles up, and you have to deal with the stuff that's piled up already. This is not about bad decisions. It's not about doing bad things. This is not a moral judgment. This is just about the fact that stuff accumulates, and you're not perfect, and neither are your teammates. We might occasionally institute a rhythmic cycle. Let's do a cleanup every now and then. And that amortizes it a bit. But honestly, the real way to understand it is it's supposed to be a continuous thing. The idea is that cleaning of the kitchen, you don't leave it till the weekend. Yeah, a friend of mine actually he lived on his own. Well, no, he lived with one other person. But they bought more pots and pans and plates for 2 people. You would look at what they had and you think, wow, that's enough for like an extended family. Oh no, that's not how it worked. That's how much stuff they needed to use in a week, and then at the weekend they would clean up. It costs extra and it creates a mess. So, how do we carry this out? How do we maintain? Maintenance is an action. The problem that we are responding to is inaction. The problem we are responding to is a problem of neglect. It is typically something we are not doing, something left undone or unattended to. And the last thought, I'll borrow from John Seddon. We can separate the way that we spend our time into a very simple model of 2 things. Demand in the sense of supply and demand in the sense of the economic sense. If I am a developer, why am I here? Why am I looking at this code? Either I am adding value because it represents the demands the customers make for the things they want that are of value to them. I am adding this feature. That is what I'm doing with my time. Ideally, we want all of our time to be value demand. Okay? That's what you want. Unfortunately, there's another kind of demand, failure demand. Failure demand is caused by a failure to do something or do something right. Like bug fixing. There's no value in that. I am working here because of a problem in the past. If you have code that is incomprehensible, if you have a class that is 10,000 lines long, you are fighting the past. You're not working in the present or the future. You are fighting the past. Your time is spent in failure demand. If you are scratching your head because you don't understand something, because it's legacy and the knowledge left the building a few years ago, that is failure demand. I don't know what the exact numbers are, but let's put it this way. I think if you're doing 1 hour of value demand per day, you are lucky. So how do we do this? How do we get better? Well, I will leave you with some very simple advice. From Annie Dillard. It's like housework. It's like all these things. It's not a thing we budget. How we spend our days is, of course, how we spend our lives. It is the things that you do now. Don't save it after the next deadline. We'll do a big cleanup. In 6 months' time, we'll be in a much better position. The best position is now. Do not fall for the goal-oriented fallacy, the arrival fallacy, that we will get somewhere and it'll all be perfect and everything will work out and we will suddenly have enough time to make things good. It is simply the small acts. And the small acts, repeated on a daily basis, will influence your code. But the most important thing is it heightens your sense of awareness. It eliminates the deep neglect many codebases experience. Thank you very much.